Welcome back to Math Zen, everyone. In this video, we are going to take a deep dive into partial quotients. This is the method many parents hate because they don't know how to help because they were taught the standard algorithm, which does still work, by the way. Contrary to popular beliefs, it has been my experience that many students actually prefer this method. That being said, let's go ahead and dive in.
Okay, on this slide, you have your first exposure as to what partial quotients actually looks like when it's completed. Before we dive into what's actually happening over there, I want to draw your attention over to the right side of the screen with some important mindset tips. Number one, we need to start thinking of division as nothing more than a repeated subtraction. Secondly, you need to realize that your goal for this particular method is to take big, comfortable chunks of the dividend away all at once. And thirdly, be open to this. I know it's brand new, but you'd be surprised you might actually like this by the time we're done going over it. Now I'm going to go over this kind of quickly because it's hard to explain without being able to show you, which I will do on the next slide. But basically, the most important thing we have going on here is that memory bar going down the side. This memory bar is where you keep track of all of the subtractions that you are making when you're taking your big chunks of that dividend away. So you'll see that we have a 10, a 10, and a 2. Well, where did those magically come from? Well, again, we used our mental math skills to realize that if I did 10 groups of 12 in one subtraction, that's actually 120. So 120 to me feels like a pretty big chunk of 264. So why don't I take that all away in one subtraction, which is what I did. So for the first 120 that you see there, I got that by doing 12 times 10. I record the 10 on the side of my memory bar so I don't forget that. I do my subtraction and I get left with 144. I ask myself again at that point, can I take another chunk of 120 away from that? And if the answer is yes, absolutely you should. So in this case, we took another group of 12s away. So we did 10 times 12 again to get another 120, and we did our subtraction again. This time, though, we were only left with 24. Obviously, we can't take 10 12s away, but if you know your multiplication facts, you know that you can get 2 more 12s away from 24. So I recorded 2 on my memory bar, and then I do my subtraction. 24 minus 24 gives us 0. No remainder here. All you're left now to do is add up your memory bar to get your final quotient. Stick with me and we'll try to work one of these out together on the next slide. All right, on this slide, we are going to attempt to tackle our first partial products problem together. Draw your attention over to the post-it to the right. Remember, the division is just repeated subtraction. Try to take large chunks of the dividend away at once. Keep an open mind and subscribe if you haven't already. So we're going to start with a dividend of 648 and a divisor of 18. We're going to go ahead and make our memory bar going down the side. And we're going to start basic. We're going to say, can I take 10 groups of 18 away, which would be 180? Yes. But we're going to take it a step further and say, could I take double that, which in this case would be 20 groups of 18? Absolutely you can. And the mental math you're doing here is just 18 times 2, which is 36, and simply add the 0. So our first subtraction of 360 is going to leave us with a difference of 288. Now at this point, you would be asking yourself, again, could I take another chunk of 360 away? And obviously you can't because 360 is too big. But could you do half of that, which would be 180? Absolutely you can. So we're going to subtract 180 this time. And when we do that, we are going to get left with a difference of 108. Again, ask yourself, can I take another group of 10 away? No, you can't. So we have to bump our thinking down a little bit. But earlier, if we doubled 18 and got 36, could I double 36 and make it 4 groups and get 72? Absolutely. So again, I did 18 times 4 to get 72. That's what I'm taking away from 108, and I'm getting a difference of 36. Now, when we do our thinking now, it's a little bit more basic, hopefully. You can clearly get 2 more groups of 18 out of 36. And when we do our subtraction, we are left with 0. So this example would have no remainder. Now, assuming that you recorded everything properly on the memory bar, all you have to do is add those pieces up. So 20 plus 10 plus 4 plus 2 gives us a total of 36. So our final quotient for this problem is 36. Excellent job if you stuck with me there. Now, before we move into a more difficult example, I want to just remind you that at the step where we did the 4 and the 2, you could have absolutely done a group of 5 and then a group of 1. It's just whatever your preference is. I find that doubling numbers is easier. Some people find that halving numbers is easier. Whatever works for you and is comfortable for you is what I would like to see you use moving forward. That's one of the reasons this method is very cool, because it allows for flexibility in the way that each of you think. Okay, on this slide here, we're going to jump into the most advanced level that you're probably going to see somebody doing partial quotients with. So before we do, again, draw your attention to the right-hand side of the screen. Remember, division is just a repeated subtraction. Try to take away the biggest chunk of the dividend you can. Be open-minded and subscribe if you haven't already. So our dividend here is going to be 631, and our divisor is going to be 14. Draw our memory bar down the side, and we say, hey, can I take 140 away? Sure. Let me double that. Could I take 280 away? Sure. Let me try to double that, though. And if I double that, that's going to give me 560, which is literally almost all of the dividend. That is the main goal of this method right here. So if we do our subtraction here, we're going to get left with 71. Obviously, you can't take another 560 away here, but you can take another 56 away. So let's just do by 4 over there on the side. That gives us 56. And then we do our subtraction, and we're left with 15. And hopefully you can see we can only get one more group of 14 out of 15, and that's going to leave us 1. So when we add up our memory bar, we're going to get a quotient of 45, and that one little lonely 1 down there is going to be our remainder for this problem. So now if you work this out with me step by step and you followed all this, you truly need to give yourself a pat on the back, because this is very foreign and it's different than probably your moms, dads, grandmas, grandpas have taught you in the past. So very good job today.
Thanks for sticking with me until the end. I know that was a lot to take in. If you commit to practicing this method and pushing yourself, I'm confident you'll find it to be easier than long division. Before we go, do me a favor and leave a comment telling me how you feel about partial quotients. So long until next time, and don't forget to find your math zen.